In this video, I'd like to introduce mathematics in a way that you probably haven't heard of before. Many of us are taking or have taken a form of pre-algebra or algebra. But we have to ask a question. What is algebra? It actually has a pretty controversial history. And so in this video, I want to begin not by lecturing us on algebra per se, but by getting straight into the controversy. And so let's get started. When we look back at the history of mathematics, we find that the ancient and medieval world divided quantity into two groups, the continuous and the discontinuous. A continuous quantity is basically whatever we can measure, say like the length of a table or the height of a building. The length and height are continuous because the line we use to measure continues on itself. The only break is the starting point and the end point. An example of a discontinuous quantity, on the other hand, is a pile of coins. Each coin is a unit. You can add coins or take away coins, but you can't split coins in half. If we try to split a coin in half, we no longer have a coin. This is why when we say, again, split a stick in half, we get two sticks. A stick is a continuous quantity, it is a magnitude, and so it's something that can be cut in half. So when we cut a stick in half, we get two sticks. But what about a human being? Does that mean that if we cut a human being in half, we get two human beings? No, we obviously get a corpse. So what this shows us then is that sticks are continuous quantities. But the number of human beings is a discontinuous quantity. However, if we were to think of the height of a human being, or the length of a human being, then we're dealing with continuous quantity. It's continuous because we can imagine a line that goes on and only starts and stops at the beginning and end point for that measurement. Now, we just spoke of the two kinds of quantity, continuous quantity and discontinuous quantity. But continuous quantity can also be divided into two groups. There is discontinuous quantity, or there is continuous quantity at rest, and there is continuous quantity in motion. We call geometry continuous quantity at rest. It studies the Earth, the Earth at rest. So the shapes in geometry don't move. But in astronomy, the study of continuous quantity in motion, the shapes do move. They are in motion. Similarly, discontinuous quantity can be divided into two groups. There is discontinuous quantity considered in itself, or absolutely, like the numbers 5 by itself, 7 by itself, 10, and so on. And there is discontinuous quantity taken in relation, or in relationship, such as the ratio, say, 2 to 5. We call the first kind of discontinuous quantity, absolute discontinuous quantity, arithmetic. And we call the second kind of discontinuous quantity in relation, music. Now, I want us to notice something. We took quantity, mathematics, and divided it into different groups. But these are mutually exclusive groups. What I mean by that is they are groups that do not overlap. For example, if something is at rest, can it be in motion? Well, no. If it's at rest, if it's not moving, then it can't be moving, right? Or again, if something is considered in itself, is it also considered in relation? Well, at least not at the same time or in the same way. So being at rest, considered absolutely and considered in relation are mutually exclusive. There's no overlap there. Or again, if something is continuous, then it is not discontinuous. In fact, the root dis in discontinuous literally means not. So continuous quantity and not continuous quantity. There's no overlap there. They are mutually exclusive. And so from this, it seems that this division of quantity is mutually exclusive. There is no overlap, which means that it leaves no more room for more subjects of study that study quantity. Now, this is where the controversial part comes up, because I don't know about you, but I thought algebra was a subject in math, right? It studies numbers. So doesn't that mean there has to be a fifth subject, algebra? Or again, what about other subjects in math, like statistics or calculus and all these other subjects? And so here in this case, we'll just deal with algebra for now, and later on in our studies, we'll approach the other subjects. So first, considering algebra. If algebra is a fifth kind of subject in math, then the logical division that we just looked at here would not be true. It would mean that the laws of logic aren't true. But the laws of logic have to be true, because to argue against logic is to use logic. It's to, in a way, reason ourselves away from reasoning. And that doesn't make sense. We can't just reason ourselves away from reasoning. That's a contradiction. And so algebra is not a subject in math. Now that sounds really weird, so I'm going to say that again. Algebra is not a subject in math. Well, if it's not a subject in math, then what is it? And why do we study algebra in math classes? Well, algebra is a method for thinking about math. That's the key term. Algebra is a method for thinking about math. So algebra is not a kind of quantity. Like number and shape are both quantities, but algebra is not a quantity. Rather, algebra is a way for us to think about number and shape. It gives us a method for thinking about number and shape together. It allows us to talk about two things that are mathematically apart, such as number and shape, because shape pertains to continuous quantity and number pertains to discontinuous quantity. And it allows us to talk about those things together. So, for example, we can ask, what does the number 9 have to do with a square? Both geometry and arithmetic cannot give us the full answer. They can help us get to an answer, but they can't give us the full answer. Algebra alone gives us that full answer. And it's not because algebra is a kind of quantity that we study, but it's because algebra is a way of thinking about math. It's a method for us to use when thinking about math. And so for the rest of this year, I want you to challenge yourself. I want you to focus not so much on solving formulas, because a calculator can do that. AI can do that. But you don't want the education of a calculator or AI. You want the education of a human being. And so instead, I want you to focus on what it means to think like a mathematician. Again, a calculator or AI can solve tons of problems, but it can't think about them in the way you as a human being can. And because of that, by figuring out what it means to think like a mathematician, you're actually answering what is the difference between the thinking of AI and a calculator, what those two things can do, versus the thinking of a human being. And so, really, your quest in mathematics isn't merely to solve problems, but it's to grow in self-knowledge and to understand what it means to be a human being, what it means to be you. So I hope this was helpful. Thank you.